All right, how's it going? Cool. Everybody here for CSE 215? Excellent. All right. So welcome to discrete structures. There's only 15 people signed up for this course, which is kind of a problem because it means we might have 45 people in here in winter. So I'm going to see if I can get some people to jump into this section. But anyway, welcome. Let me start off by passing around a couple of things. The first is a sign-in sheet. And if you were registered as of a few weeks ago, your name should be on here. So sign next to your name and fill in the little circle next to your name. That'll be what I use to record attendance. If your name's not on here, go ahead and write your name on a blank line on the bottom and then come talk to me at the break. And we'll do a ad sheet for you to get you into the course. So let me pass this around. And then the other thing I want to pass around is just kind of a student information sheet. So I'm going to ask you for the following information. Let me know what name you want to be referred to by. That can be pretty much anything. Tell me what your pronouns are. But then also give me your name as it appears in Canvas right now so that I can link you to your Canvas information. And then sort of self-assess, just kind of on a scale of 1 to 10. 1 is very much and 10 is not at all. How comfortable are you with Boolean logic? So the stuff that you do in Engineering 250 or in one chapter in CSE 120 when we talk about logic operations, ands, ors, things like that. How much do you remember about that? How comfortable were you with it when you knew it? So 1 is extremely comfortable, 10 is what are you talking about? How comfortable are you with programming in general, and how comfortable are you with programming in C? So I think everybody here has had CSE 121 or an equivalent. So just kind of at this point, where's your comfort level with that? Are you taking CSE 224 right now with me? If you're not, then you need to send me an email today with the subject line, need a Linux account. Okay, because you're going to need to do a couple of programming assignments in this course, and I'd like you to do those on the same machine that we're using for the computer science sequence, and it's not the CTEC machine you used from 121. Okay, so if you're in 224, you'll already have an account. If you're not taking 224 this quarter, you don't have an account yet unless you've talked to me. So send me an email and let me know you're not taking 224, and I'll make an account for you. And I don't know, a couple of sentences if you feel like it. Where do you want to be 10 years from now? Just kind of like, academically or otherwise. Just some information. So those are just for my own benefit. I'm not going to post them or anything. So no pressure. All right, I want to start off by going through Canvas a little bit. So, anybody not have access to Canvas? Okay, but you will, right? Okay, yeah, because you're logged in now. All right, so Canvas is mainly where we're going to go for resources related to the course and for homework assignments and due dates and things like that. So fairly heavy use of Canvas, and I'll post announcements here also. So I want to run through some of these details, the course policies, and so on and so forth. And then we'll start working with some of the material. So let me go through the syllabus first of all. So this is a discrete structures course. Introduces discrete structures and analysis techniques for computing, but this is geared towards computer science students. Okay, it's somewhat of a math course. It's logic. It's some philosophy, but it's with an eye towards how does this stuff apply to computer science. In some sense, it's the theoretical underpinnings of computer science. So the stuff we're doing in here will eventually, in different ways, feed back into what we're doing in CSE 224 and especially 222 in winter, our data structures in C course. So it should be fairly directed material. So my name is Nick Macias. I've been teaching this course, well, I created the course a number of years ago, and I've been teaching it since then. And it changes tone and characteristic every time that I offer it. I did it as a full-on flipped course last winter, and I'm not really flipping it this time, but we're going to spend a fair amount of time working on problems on the board, so it'll be more active learning. So my email, nmacias@clark.edu, you can always reach me through there. My office is 115. It's the second office on the other side of the collaboratorium. It's right next to Izad's office. And my office hours are on that website. They're on my door, and it's basically Tuesday, Thursday, 7 a.m. to 9:30 a.m. It's 12:30 to 1:55, so about an hour and a half course that we have here, 3 days a week. We'll take a break somewhere around halfway through, so about a quarter after we'll take a break generally. That's a really good time if you want to catch me and ask me a question or something like that. That always works. I'm not going to be available after class though. Okay, when class finishes, I'm pretty much going to leave. So if you have questions, try to ask me during the break or during class, right? But I may have to just say, sorry, I got to run and leave. Especially on Mondays, because I have a class 5 minutes after this one ends, and I have to like get supplies and stuff. All right, so the textbook is a free text, Applied Discrete Structures. It's available from this link here. You don't need to print it out. I don't recommend printing it out. I don't recommend reading it cover to cover. It goes over a lot of stuff that we won't go into, and there's some stuff we'll go over that's not listed in that text. Okay, but it's a good reference, and I'll often give homework questions from that text. And the questions in there, the odd numbered ones have solutions in the back. So it's a good way to practice material if I give you questions 2, 4, and 8 to work on, right? You can look at question 1 or 3, it's probably similar to question 2, and maybe get some extra practice that way and so on. So it's a good resource, and to me it's really well written, and it's an open access book. All my courses use open access texts, so no charge to you. Course outcomes. I'll let you read this because most of these words may not mean anything to you at this point, but these are the things that we're sort of guaranteeing we're going to go over in this course. Now there's other stuff we'll go through and so on, but these are the specific outcomes that we need to cover so that when you have passed this course with a C or better, somebody like WSU, for example, knows that you've covered certain topics and they're okay for you to go on and use this as a prerequisite. So these are the things we're definitely going to go through, but there'll be other things as well. And you're assessed on these through combinations of some programming assignments, homework, tests, quizzes. Tentative schedule, don't pay attention to because we're not sticking to this as of today. We're going to go off it. We're going to do propositional logic probably week 2 or 3. So we're going to start with week 4, which is set theory today. But this is the collection of stuff that we'll cover in some semi-random order this quarter. All right, grading for the course. So homework will be 15%. Homework will generally be once a week, and it will be similar to homework that we're going to do as a class on the board. Okay, so usually after break we'll split up into groups, and I'll pass out a set of homework questions, and you'll work on them as groups on the board, and I'll walk around and see what you're doing, and this will be your chance to really sort of like learn the concepts. And then there'll be homework posted that you'll actually do on your own and turn in for a grade. And generally, I'll pick one problem from the homework and grade that as your homework grade. Sometimes I might pick 2 or 3 problems, it depends, but I'm not going to tell you ahead of time which problem to do, so you want to do them all. There's a few quizzes throughout the term. Those will be a total of 15%. Those are a closed book, open note, a few pages of notes allowed. A couple of programming assignments worth 10% of your grade, attendance worth 10% of your grade, and then a midterm and a final 25% each. It's a pretty straightforward grade calculation. And just a note here, there's an engineering computer science club that meets Fridays at 12 o'clock, so you can catch them right before this class. It's in room 126 down the hall. Starting this Friday is their first meeting. unfortunately, we got to be here at 12:30, so you can only catch a half hour of that. But some years they have pizza and stuff like that, so that makes it worth admission by itself. But that's a good resource to just sort of like meet people and kick around ideas, stuff like that. All right, if you were in 224 this morning, you already heard me talk about this, but I'm going to talk about it anyway in here. So there's a Disability Support Services office available here at Clark, which is there really to help ensure that every student is sort of on an equitable footing as far as their ability to come to class and listen to lectures and take tests and so on and so forth. So if you feel like you're in a situation where, for example, you might benefit from having extended testing time because you have difficulty reading, there's dyslexia or something like that, or you would do better testing in a low distraction environment where you don't have to listen to a fan blowing in the doorway, or you need a note taker to take notes for you because you have difficulty seeing the board and so on. Any kind of accommodation that you think might help you be better able to be successful in your classes, right? There's a DSS office that is here to help figure out how to make those accommodations possible. So if you think you're in that kind of situation, talk to me, talk to the DSS office, go visit them in Penguin Union Building, room 13, visit their website, email, there's a lot of ways to reach them. Okay, easiest way, if you're not sure, just come and talk to me and we can go from there. It's a great resource. I strongly recommend taking advantage of it. I have students who will come to me the last week of the course and say, I get really freaked out during tests. That's why I got an F on the midterm, because, you know, when I see the test in front of me, my brain goes blank. And if I could just, you know, such and such, I'd have a better okay, that's a little too late to get things set up to be able to test, right? You want to figure this out as early as possible. And this cuts across all classes, right? If there's something that would help you in all of your classes, right? Figure out the process. Come and talk to me. We can work through it together. Or talk to one of your other teachers, or just go straight to the DSS office, whatever you like. But it's a great resource, so definitely take advantage of it if you're in that situation. All right, and so the non-discrimination policy, I'm going to read this verbatim to make sure that everybody has heard this at least once, or probably twice if you were here this morning. So Clark College's non-discrimination policy. Clark College affirms a commitment to freedom from discrimination for all members of the college community. The college expressly prohibits discrimination against any person on the basis of race, color, national origin, disabled veteran status, sex, sexual orientation, age, gender identity, creed, gender expression, Vietnam-era veteran status, religion, marital status, or the presence of physical, sensory, or mental disability. The responsibility for and the protection of this commitment extends to students, faculty, administration, staff, contractors, and those who develop or participate in college programs. It encompasses every aspect of employment and every student and community activity. Okay? So we want you to spend your energy learning discrete structures, learning C programming, learning physics, whatever it is that you're taking, not worrying about, is this person going to make annoying comments to me today that are going to, distract me and cause me to have to deal with something. So if anything is going on, or if you think anything is going on, or you're not sure, right, come and talk to me, talk to another teacher, something, okay? And I can help point you to some of the resources that are available on campus, Title IX stuff, things like that. There's a lot of support for this, okay? And the college takes it really seriously. So any weirdness or anything going on, right, say something to someone. Make sense? Okay. I'll let you click through to the Code of Student Conduct. That's pretty boilerplate, but make sure you've read it at least once in your time here at Clark, preferably earlier rather than later. Same with the ECS department policies. You can click through to that and read that. Most of it's pretty obvious stuff. All right, syllabus questions. All right, so there's also additional course policies that relate to this particular offering of CSE 215. So meeting time, Monday, Wednesday, Friday, 12:30 to 1:55, right here. You figured that out already. That's my name, Nick Macias. You can call me whatever you like, by the way. Office hour schedule, office. Okay, Discord server. I'm going to try to discourage email, either direct email or Canvas emails, for most questions. Okay. Now, if you have a question that really is between you and me, you know, a scheduling issue, you know, some question about, I'm not understanding this course, is it really important for me to take it, or what should I take next quarter, or something like that, go ahead and use email, okay? There's no harm in trying email. But if it's a question that's sort of more general, question 5 asked us to talk about the power set, but we never discussed the power set. Are we supposed to do that, right? I'm going to ask you to use a Discord server, okay? So it's a group chat kind of thing. That S should not be a link. It's a typo. So Canvas has a link to the Discord server. This one's expired. But if you come down here, there's a link to it. So post your questions there, okay? If you send me an email with a question and I think it belongs on the server, I'll probably just respond and say, great question, go ahead and post that on Discord. Okay, and that's what that means. So we'll figure it out on the way. You know, what's right for what. And like I say, there's no harm in sending me an email. I just can't respond to, you know, 50 individual emails every day. If they're questions that can be addressed in a general forum. And if someone asks a question and you have a solution to it, go ahead and post the solution, right? If someone's not sure what the power set is, go ahead and post your understanding of it. It's a great way to reinforce your own learning, your own understanding of concepts. And I'll monitor this channel and I'll chime in, you know, if something else needs to be said, and if somebody asks a question and nobody answers it quickly, I'll probably go ahead and answer it. But this way I can answer it one time in one place, and then when somebody else is like, I don't know what the power set is, they can, you know, find it there. So let's try to use Discord as our main communication as a class. Okay, and email if you need to talk to me one-on-one.
Can you explain what the word Discord means?
I don't know why it's called, but if you click through on here, and Canvas won't open it, but just click through to an external. It's basically a chat thing, so if you have it installed, it'll do one thing. If you're running it from the web, it'll do something else. If you have it on your phone, it'll do something. But basically brings up, you know, welcome to the beginning of the CSE 215 general channel. So for 224, people got chatty, and so it's just, you know, people are posting comments to each other, but you could put something like, hey, you know, but yeah, Julie's a rebel texting in class. So if we go to the 215, I don't know what a discrete structure is. And somebody might say it's the name of the course, right? So, and it'll be goofy in the beginning, but it'll calm down over time, I think. And so try to use that. I haven't done this before, okay? Normally we're stuck with email or the discussion area of Canvas, and most people don't use it. A lot of people who are gamers use Discord anyway. The engineering club has a Discord server. It's a fairly common resource. WSU uses Discord a fair amount, and so it's just an easy way to sort of have some conversations going. So does that make sense?
Well, yeah, I understand what it is, but the word Discord seems.
I don't know the etymology of it. I'm sure you can find it.
It just seems a strange word to use for that entity.
Well, let's check back here later and see if someone knows. All right, so that's Discord. Any other questions on that? You can install it as an app. You can put it on your phone and all kinds of stuff. And it's free, so if you don't have a Discord login, go ahead and sign up, and it's pretty harmless. Okay, this should be the same assessment that was in the syllabus. I should take it out of the syllabus, but it's the same thing, same percentages. Keys to success. So what do I think would be most useful to being successful in this course? We're going to spend a certain amount of class time working on problems on the board. That's really where your learning is going to happen. Okay, if I could stand up here and say something and magically it would program your brains to understand the concept, I'd be famous, right? I'd be that teaching hood that Spock had, you know, in Star Trek. There's no way I know to do that, right? I could just make a video of me talking and everybody would learn discrete structures, right? It doesn't work that way. You learn the stuff by using the concepts, okay? And traditional classroom, you know, I stand up here and I lecture for an hour and a half, and then you go home and you work on problems. And if you can't do them, what do? Well, you get frustrated and you know. So a flipped classroom is the opposite. The lectures are done at home. So I would post lectures as videos, and then we'd come in here and we'd work on problems as a group. So this isn't a full-on flip. I'm going to lecture up here, and I'm going to lecture for like half the class, and then we're going to work on problems on the board together, where I can see what you're doing and you can ask questions and I can point you in the right direction and so on and so forth. So we'll be spending a lot of time doing problems on the board. When we're doing that, make sure that you're actually working on the problems yourself. We're going to work in groups because there's not enough space for 15 people to be working as individuals. But make sure there's not one person who's hogging the marker and doing all the work and everybody else in the group is just watching, right? Take turns and make sure that each of you understands what's going on, because this is basically what you're going to do on your exams. You're going to be working out homework problems, but you're going to be doing them alone. So you want to make sure that you've had practice for that. Try to come to every class, try to come on time. I know it's a big campus, sometimes you got to come from Bauer Hall or something and it takes a long time to walk here, but try to come to every class as on time as possible and plan to stay for the entire class. And try to use the class time to learn the material, right? Don't just spend class time writing down everything that I say and then go home and read it and think about it. Try to think about it while we're in here working with it, okay? I'm recording all of the lectures. I'll probably turn it off when we're doing problems on the board, but I'm recording the lectures, so the things that I'm saying up here you don't necessarily need to write down. Now it can help you remember things to write them down, but you can always go back to the lecture videos and see what was said. So try to be an active participant, right? Try to think about the material and work with it while we're in here. And try to avoid distractions and tangents as much as possible. It's hard to do. It's an hour and a half. That's a long time, right? Most of us, our attention span is about 5 minutes. Mine is, at least. But, you know, we'll talk about some things that are going to be probably pretty intriguing. We'll get into some philosophy and some existential stuff. If you find something grabs your attention, just put a note in your margin to look it up later. Try not to go to Wikipedia right then and there and start reading about it, right? And then come back 15 minutes later and say, I don't know what we're doing. So try to stay present as much as possible. And if you find yourself slipping somewhere else, right, when you notice that, just come back to where we are now. Don't beat yourself up. I'm a terrible student, you know, why do I do that? Just come back to where we are, be present, right? Try to stay here as much as you can. So attendance is taken. Is the assignment sheet still going around? You got it? Okay. If you come into class late, just come up at the break or something and make sure that you sign in. Thank you. And you get a point per day for showing up, and those get accumulated across the whole quarter, and then you get 10% of your grade from that. So if you don't sign in the beginning, sign in sometime that day. Exams are closed book. I'll let you have 4 double-sided pages of notes. That should be plenty of notes. Okay, I don't want it to be a limit, but I don't want to say open note because then people don't study and they just bring in, you know, 100 pages of notes and spend the whole time flipping through it. So 4 double-sided pages, closed book otherwise. Not taking any late work unless you really, really let me know ahead of time and it's a really good excuse. Okay, letting me know 2 days after an assignment was due that something happened and you weren't able to do it, it's probably going to be harder to wiggle around. For the programming assignments, write the code yourself. Don't look at other people's code and try to modify it into your own and so on. We'll talk about this when we get to the first assignment. But basic common sense, you got to write the code yourself. It's got to be your own work that you turn in. Again, send me an email if you're not in 224, meaning you don't have an account on the Linux server, and I'll set you up for that. that's pretty much it for that. This will be the link to the lecture videos. I'll open that up after I post today's video. And it's just a YouTube channel, and they should all be up there. That's the link to the Discord server. That's the link to the main textbook. This is a link to an additional textbook that covers some of the material that's not in the first book. And I may assign some homework from here, but again, it's there, it's free. You don't need to download it or print it and so on. Some stuff on mathematical induction. We'll be getting to that in a few weeks, but those links are up there already. Your first homework assignment is posted. And this is due on the 27th, which is Friday. And so it's a few problems from chapter 1 of the textbook, okay, the main textbook. And 1.2 number 8, I said think about number 8 and make a try. That's a more challenging problem than some of the others. So that's not one I'm going to grade, okay, but I want you to think about it and see what you come up with. And we'll look at these in some detail later. I have a guide to writing up homework, and it says, please read, this will affect your grade. Oh, by the way, you know, even though I like to think that everything I say up here is important, the reality is 90 minutes a day, 3 days a week, you can't pay attention to everything I'm saying. So I knew a teacher, he would like stamp his foot when he was about to say something really important to get people's attention, which seemed a little violent for my taste. So occasionally you'll see this pop up on the screen, okay? That means what I'm telling you is important, okay? So that's your subtle hint to pay more attention. So this guide to writing up homework, please read, this will affect your grade. So let's take a look at this. Okay, this might be really picky on my part, but if you had Engineering 250 with me in spring, this is where I started doing this, and it made a big difference. And this will serve you well throughout your academic careers. So I'm going to be very specific about how I want you to write up homework, and you can read through this on your own, but let me give you the basic punchline. I want your homework to be something that is easy for me to follow. Okay, so 8.5 by 11 paper, right, like this with clean edges. Okay, no frilly things on the end, no 7 by 9 pages, things like that. It's important because homework gets lost really easily. If there's edges on the side, it grabs other sheets of paper. If your homework is really small, if it's not stapled, things get lost. If you have to cross something out, cross out a single line. Okay, don't scribble. Highly recommend working out homework problems on scratch paper first. Okay, figure out how you're going to write the solution, how you're going to develop the proof, how you're going to do this calculation, and so on. And then when you've got that figured out, put it onto the sheet that you're going to turn in. Unless you like, you know, the gamble of can I do this right without making a mess out of it the first time. Number 2, pencil or some other soft lead that's easy to read. Okay, I've had people who use like a 9H and it's like really, really faint and hard to see. Make it easy to see. Print neatly. 8.5 by 11. You can use lined or unlined paper. Okay, up to you. Standard engineering paper, which is the green graph paper, that's fine also. Put your problems in order. Okay, this is what motivated this, because I was getting homework and it's like question 1, question 7, question 2B, question 3A, question 2C. Put your questions in order, okay, so I don't have to go hunting to find which question. Single-sided, okay, with apologies to the forests, just right on the front, okay, and go on to a new page. We'll recycle. For each page, okay, your homework's got to be stapled. There's a stapler over there, so if you come in and it hasn't been stapled, you can staple it that way. Staple it in the corner, okay, not right here. I had someone do that as a joke once. They got the staple right in the middle of the page somehow. It was awesome. And then on the top, right, your name, the class, CSE 215, the homework number, the date, and then the page number, 1 out of 5, 2 out of 5, that kind of thing. Okay, and put that on the top of every page so that if the staple comes out, I can still find it. And this may sound obvious, right? You would not believe how many assignments I get without a name on it, or with somebody's first initial on it. And it's really hard in a class of, say, 60 people, like 224, to know what goes with what. All right, so page layout, that's just that format up here. Keep the left margin empty, and you can decide where the left margin is, but keep that empty except for the problem number. Okay? And basically just work linearly from top to bottom. Don't go across, back and forth, left to right. Don't go down and then skip down here and then jump back up here, right? Lay it out in a clear, organized way. The reason is because you're going to be doing a proof, for example, right? And there's several steps to making a proof. And I can look at the proof and say this is wrong and give you a 0. Okay, but it's better if I can look at your proof and say, oh, you were on the right track and you skipped one step over here, but then the rest of this was fine. Okay, so you get a 95 out of 100 on that. So you want me to be able to follow what you're doing, which means you want to organize your work in a way that's logical to me. Okay, and this is what's going to make it logical. So all the work for a problem should be organized from top to bottom. Do not work in multiple columns. Work strictly from top to bottom. If you reach the bottom, go to a new page. Make sure the flow is logical and ordered. At the end of the work, circle your answer. If it's the kind of thing where there's a single answer. If it's a proof, the whole thing is there. But if it's like, how many pizzas can you order? If there's 3 types of crust and 4 types of toppings and 2 types of sauce, show me your calculations. When you get to the final answer, you circle that. Okay, does that make sense? So you can read that and go through the details, and we'll, first assignment, if it's not doing something that I want you to do, I'll let you know that, and it won't cost you points, and we'll work up to this. I guarantee if you get into the habit of doing this, though, all your teachers are going to love you, right? You may not know anything about physics, but you turn in your physics homework like this, they're going to be like, this is so beautiful, I'm going to give you an A anyway. Maybe.
Maybe.
All right, so let me close out these things. All right, so let's go back to, oh man, it closed out Canvas. All right, so homework 1 is posted. 2 quizzes, October 9th, November 22nd, 2 programming assignments, end of October, end of November, midterm November 1st, and final December 9th. All right, any questions on the administrative stuff?
So there is not a computer programming assignment due until October 25th?
Correct.
Okay.
And I don't think I've posted what the assignment is yet. Yeah, it's not posted yet. I'll post it up in probably next week.
Give me some time to...
Yeah. And the programming assignments are really sort of intended to just take some of the concepts we're talking about and give you a chance to explore them in a computer domain, right? Because we're computer science here for the most part. And so it's sort of trying to tie these things in. So what is this course? Discrete structures. What does discrete mean? What's that? Say again?
Quietly.
So there's discrete as in let's be very discreet about this, right? Let's not let other people know about this. That's one meaning of the term. That's not the meaning that's going to apply here. There's a different version of a different meaning to the word. Can you think of a word that's the opposite of discrete? Sort of. It's a weird word. Say again?
Explicit.
Yeah, sort of explicit. All right, here's a graph of y equals x squared. And the assumption here is that x is what we call a real number. It could be 2, it could be 1.5, it could be 3.1415. It could be, you know, any number that we think of. And for each of those values of x, there's some corresponding value of y, which is the square of x. Okay. And we can describe this function, not to give bad flashbacks to Math 151, we can describe this function as being continuous, meaning that as x changes, the value of y also changes. And it doesn't do something like this. It doesn't jump around, right? It changes smoothly. That's a continuous kind of thing. And it's continuous partially because the values that x can take on, there's a whole bunch of values that x can take on. For example, it could take on the value 2. It could take on the value 2.1. It could also take on a value in between those, like 2.05. And it could also take on a value in between here and here. Here's the weird thing. When you pick any two numbers, I can find a number in between them. It doesn't matter how close those numbers are to each other. You pick any two numbers that are different from each other, I can find a third number that's in between those two numbers and different from each of them. That's kind of cool. So 2.00001 and 2.00002, I could pick 2.0000015, and that's in between. Okay, that's the nature of continuous things. Discrete is a very different situation. For example, if we consider the set of integers, whole numbers, x might be equal to 2, x might be equal to 3. There's no possible value of x between 2 and 3. There's no integer between 2 and 3. And so if we were to graph y equals x squared, when we're talking about integers, it looks something like this. And we could say these points are discrete, or this is a discrete set of points. They're separate from one another. And there's nothing between here and here, and there's nothing between here and here, between 1 and 4. Now over here, 1 squared was equal to 1, and 2 squared was equal to 4. Well, I could pick some number between here, like 3. There's some number here whose square is equal to 3. Right? They're all kind of jumbled next to each other with no real jumps between them. Here, everything kind of jumps around. Our x's jump from 1 to 2 to 3. Our y's jump from 1 to 4 to 9. This is a discrete situation. Okay? And this is basically what we're studying. We're mostly working with the things that are sort of individual pieces, as opposed to a whole bunch of things that are really, really close next to each other. That's a hand-wavy, intuitive explanation that will start to make sense as we work with this stuff. But just something to kind of come back to in your brains. Discrete versus continuous is sort of the standard breakdown. And this is a computer science-y kind of thing. We work with integers in C. We work with floats in C, but they're not really real numbers. Because do you remember how many bits it takes to store a floating point number? Any guess is probably pretty close. Make a guess. Say again?
8.
Could be 8, could be 16, could be 32, could be 64. It's probably a power of 2. On our Linux server, it was usually 32 bits for a float and 64 for a double. But it's a finite number of bits. 32 bits, there's only so many combinations. There's actually 4 billion combinations. Well, that's a lot, but that's not enough to represent every possible number. There's only 4 billion numbers we can represent. So our numbers in C, even though they're real numbers, they're floats, they're still discrete, right? Our lines of our program are discrete. There's a first line, there's a second line, there's no line in between. Our memory locations, if you've done Engineering 270, our file registers, their addresses are discrete. This is file register 0, 1, 2, 3. There's no file register 2.7. Really cool things happen when you get away from that, when you try to design a computer that's continuous instead of discrete. That's one of my research areas. Topic for a different conversation, but it makes life very interesting. So computer science, we usually deal with discrete things, so discrete structures ties in very nicely to that. So there's computer science in this course, there's logic in this course. We're going to spend a few weeks talking about propositional calculus. How do we construct formal proofs of statements? And that's useful because when we write a program, sometimes you want to know, does this program work? How do we show that this program works? Well, we can construct a proof that a program or an algorithm works. You've probably heard of bubble sorts, right? It's a way to sort an array of numbers. How do we know a bubble sort works? Just because Scott told us this is a bubble sort, it's good? How do we know it actually works? Well, we can prove it. We don't do that. If you take an algorithms course, which is usually, a third-year course, you'll do things like prove that certain algorithms actually do what they say they do. So proof, formal proof is another part of computer science, and we'll spend some time talking about proofs in here. We'll talk a lot about logic and math, and we'll talk about some weird stuff. We'll get into some strange spaces. And a characteristic of the material in this course is the following. We'll often start with things that we believe we understand very well. We're going to do this today. We're going to start with set theory. And what's a set? It's a collection of things, right? Here's a set consisting of two markers, right? Here's a set consisting of a marker and a mouse, right? How hard could it be? But by Friday, we'll see that this idea of a set can take us into some really, really weird areas of logic and philosophy. So we'll usually start with something we understand already, and we'll build on it, and we'll take it to a point where we get into some non-obvious stuff, and that's where the course gets really interesting. All right, questions up to here? All right, so I think I lied to you. So let's take a break, and I'm going to actually lecture on sets for a little while. And I don't know if we'll get to the board today. We'll definitely get to the board on Wednesday. But let's take a 5-minute break, and then we'll come back. We'll start talking about set theory, and we'll build from there, okay? And if you need to register for the course, come up and see me. I'll give you an ad sheet and so on and so forth. Otherwise, go ahead and stretch your legs and your brains for about 5 minutes.